Hey everyone, so welcome to our next section. As a recap from our first section with molecular compounds, let's see if you can list the 7 elements that exist as diatomic molecules. And then after that, just if you can draw out each of those elements as dot diagrams. So pause the video, give it a try, and come back when you're ready. Alright, so our 7 elements, if we remember, we take a look at our halogen group. We start at iodine and we basically make a 7. So we've got iodine, we have bromine, chlorine, fluorine, so bromine, chlorine, and fluorine, and then we start to turn left and we go through oxygen and nitrogen, and then to finish it off as hydrogen. And so to draw dot diagrams for each one of those, each of our halogen group will be the same. So with each of these, our dot diagram should have 7 around them. Because they all are in the same column. Oxygen has 6 around it. Nitrogen has 5 around it. And hydrogen just has a single one. So dot diagrams for all of our diatomic molecules. So whenever these things exist in nature, they exist as groups of 2. So you'd see O2 or N2, H2, I2, and so on. So an electron dot structure, such as a dihydrogen, 2 hydrogen atoms, represents the shared pair of electrons of the covalent bond by 2 dots. So these dots, what we're going to start to go through, they can often be replaced by dashes. And so we take our 2 dots, replace it over as a dash. When it's replaced as a dash, we have a structural formula which represents the covalent bonds by dashes. So structural formulas connect to our dash model. They show the arrangement of covalently bonded atoms. So if I take 2 different hydrogen atoms, each one of them, so 2 different hydrogen atoms, we'll maybe represent one by an X just to show a little bit of difference. Each one of them want to gain that extra electron to fill that first shell. And so when they combine, basically they're combining such that they're sharing the electron of the other hydrogen atom to make it stable. Now, this hydrogen atom has 2 electrons through it, and this hydrogen atom, our second one, also has 2 through it. And so each one is sharing those electrons to make a covalent bond. And we can actually do that for the other diatomic molecules, and there is an exception which we'll see in a little bit that just goes along with that. So we have a structural formula, which is our dashed lines, and we have a molecular formula where we just write out the symbol with the number of atoms that are present. The halogens also form single covalent bonds in their diatomic molecules. And so similarly to how we did our H structure here, I could also take 2 chlorine atoms, because Cl2 can exist as a diatomic molecule, and it wants to exist. And again, I'll just show separate electrons by X's in this one, just to show that there is a little bit of difference. And when I combine them together, I can move these around so they overlap each other. So basically what would happen is that these 2 atoms would make that connection together, and they would basically make a chlorine to chlorine combination where I would have my dots around the outside of my chlorine with that covalent bond in between. So for this one, to draw 2 dot diagrams for fluorine, and then what would they look like as a diatomic molecule. So pause the video, see if you can draw it, and come back when you're ready. So we just kind of went through this 2 dot model. So we've got 1 fluorine atom. Let's say that it just has our dots around it because it's in the same column as chlorine from our previous slide. And so we can see that the 2 fluorine atoms that are here, I'm just going to represent them by different electrons. And when they start to pair up, they would pair up like that. And so they would share their electrons each, because each fluorine wants to have 8. And so really when they pair up in the end, it's just going to be fluorine with a covalent bond to the other fluorine. And really those dot structures on the outside, you're going to start filling those in, that they kind of just become second nature, that halogen groups have 7 valence electrons, and so in order to fill their octet, they're going to have that full 8. And so every covalent bond line kind of stands as 2. So also notice that there's valence electrons that don't get shared between the atoms. And so if you kind of have drawn out these so far, you notice that oftentimes we'll put them in groups of 2. So these unshared pairs of electrons, we often refer to those as lone pairs. And a lone pair just stands for a group of 2 electrons that are not part of the bonding process. They're part of the valence shell, but they don't get bonded. So you can draw electron dot structures for molecules of compounds in the same way. So we can take not just the diatomic ones, but take things like water, for instance. As an example, it wants us to draw dot diagrams for each of the atoms in a water molecule. How do you think they combine to form a molecule of water? And so take a second and see if you can sketch out a water molecule, see if you can make it work. I guess we have to first remember that water is H2O. So start with the dot diagrams for 2 hydrogens and an oxygen, and see if you can have them overlap in such a way that every atom has what it needs to be stable or to be full. So pause the video, give it a try, and come back when you're ready. Alright, so we're going to start with our oxygen atom, and oxygen has 2 lone pairs and then 2 single pairs, so it can form a bond with the hydrogens that are left over. And so really this is kind of uneven. If we were to draw this out based on electron repulsion, this object would actually take kind of a bent shape to it, and so the oxygen atom that's here would actually have 2 electrons that are present on the top, equally pushed apart, and then it's going to have hydrogen atoms on the corners that are going to kind of give it this bent shape. And so hydrogen, if we take a look now in terms of the rings that are around those valence shells, hydrogen has what it needs because it has 2 here and it has 2 here. And oxygen has what it needs because oxygen has 8 around its outside. So if I were to draw these out and show the covalent bond lines between them, oxygen would have its 2 lone pairs, and then it would have hydrogen coming from there. So it would take on this bent structure. And so our picture here just kind of shows a water molecule with the required amount of electrons and overlap in the valence shell that it needs. So the next one is to try to draw the electron dot structure for ammonia, for NH3. And I have a couple of examples here. I have NH3 and I have CH4. So I do have model kits in my room, and so when you get to this section, I would like for you to try to build it and see what it looks like. So just ask me and let me know that you're ready for the model kit, and I'll get you set up for this part. And then after you build it and see how it looks, we'll try to draw it out and make sure that it makes sense. So pause the video, let me know that you're ready for a model kit, and we'll get you set up. And then we'll get going for NH3 and CH4. So when you're ready to draw and you're ready to move on, just come back and I'll draw out the structure for it and go through that way. Alright, so for NH3, we start off with nitrogen. Nitrogen has 1 lone pair and 3 bonding pairs, which is good because hydrogen is each bringing 1 electron. Hydrogen's looking to be stable, so it now has 2 in its outside shell in each case. Nitrogen now has 8. So really, nitrogen, with its lone pair, is going to form 3 covalent bonds with the hydrogen atoms that are around it. And hopefully, when you drew this out, compared to building it, you can see that there's a big difference in how this looks when you build them compared to just drawing it on the page and getting a completely different shape than what you would kind of expect. So also take a look for CH4. And again, if you're just at that point, I would pause the video. I would go and take a look at how to build CH4, and then we'll draw it out here. So just pause the video again and build, and then come back when you're ready. All right, so carbon has 4 potential bonded pairs. We have 4 hydrogens, so it works out nice. Hydrogen's each going to want to share an electron. So hydrogens. And so carbon has 8 around its outside, so it's good. Hydrogen has 2 around its outside, so it is also stable. And we have a methane structure that's balanced. And so we can kind of draw these out, but also see how they're a little bit different when they're built. So if we were to look at the electron configuration of carbon, what we would actually see here, taking a look at the arrow, the orbital filling diagrams, we have 1s, 2s, and then 2p2. And realistically, if we were to just look at this and think, okay, how many bonds could carbon form based on this? Carbon's always wanting to look for pairs, and so really we would think it would just want to take in 2 extra atoms that would kind of stabilize it. That would make this CH2. But we know from looking at our last drawing that doesn't work. We need 4 hydrogens. And so how does the electron configuration kind of justify that, or how does it work? Well, as it turns out with experimentation, what actually happens is that they take one of the 2s2 arrows, and actually it gets promoted to a 2p2. And so it actually does make it look a little bit less. So really this becomes 2s1, and this becomes 2p3. What this enables, it takes a small amount of energy for this to happen, but the stability of the resulting bond is a lot more favorable than just having CH2, because now I could have 4 bonds which completely satisfy filling all of those shells, rather than still having a gap and wondering that you've got 2 filled, what's going to happen with this spot. And so by promoting that 2s electron up, we can actually fill all 4 of them, and it makes quite a strong structure. So there's examples that are like that throughout, but right now I'd like for you to try questions 7 and 8. They're on page 220, as well as draw dot diagrams for each of the following that are here. It's the next assignment that's on the list, so pause the video. You can do that little assignment part. Please show me when you're ready, and before you move on to the next video, and let me know if you have any questions.